All right, you are welcome again. We are talking about double or multiple integral. Let's take a look at this question. Evaluate the double integral over the indicated region. The double integral over the region R, 2x minus 4y cubed dA, where the indicated region R is minus 5, 4 and 0, 3. You get it right? Good. Solution. Please pay attention to this, okay? So here we are talking about double integral. And then this double integral is a way of finding the area of an indicated region. Our facility could not help us to draw the graph so that you understand the area of the region that we want to find. Okay, but nevertheless, we can work with this. Now let's go. Here we have the region minus 5, 4. We're going to take this minus 5, 4, this region to be the x region, and then 0, 3 to be the y region. Okay, and then this minus 5, 4, we're going to take it as the boundary on the x. You get it? That's the region, the boundary on x, and then 0, 3, the boundary on y. So we're going to have the integral over the region minus 5 to 4, or you say from the boundary minus 5 to 4. And then we say that this is for x. Then we have another integral from the region 0 to 3, or for the boundary 0 to 3. Then we have 2x minus 4y cubed. So here now we'll say dy dx. We started with x, we will end it with x. So here we're going to have the integral from minus 5 to 4, and also the integral from 0 to 3, 2x minus 4y cubed in bracket dy dx. We started with x, we end it with dx. You get it right? Good. Now, from here, we can split this into two. Here we have the inner part of the integral and then the outer part. So you can take the inner part first before taking the outer part, and it will still give you the same result if you take the outer part first before taking the inner part. Okay, good. In this lesson, I'm going to take the inner part first. Please, I want you to take the outer part first before inner part and see whether we're going to arrive at the same answer. Okay, so now finding the inner integral with respect to y, and then you see that the inner integral is with respect to y. So here we're going to integrate with respect to y. We are going to hold every other variable constant. The x, we're going to hold it constant and integrate only y. All right, good. When we do so, we have the outer part, which is the integral from minus 5 to 4. Now let's open the bracket now and integrate. When we integrate 2x, what is it going to give us? We are going to take this 2x as if it is a number. So when you integrate a number, it will introduce that value. We are integrating with respect to x. So when you integrate 2x as a constant, it will introduce y, the variable that you are integrating with respect to, into it. So here we're going to have 2xy. So we integrate 2x as a number or as a constant. Then when we integrate it, it's going to give us 2xy. You get it right? Good. Now we have minus. When we integrate 4y cubed, it's going to give us 4y raised to the power 4 all over 4. It's going to give us 4y raised to the power 4 all over 4. Now we have over the region 0 to 3. Then we have dx. You get it right? We integrated with respect to y. So here we have 4y raised to the power 4 all over 4. So when you say 4 divided by 4, is going to give us 1. 1 times y, we have y raised to the power 4. So here we have the integral from the region minus 5 to 4 2xy minus y raised to power 4 over the region 0 and 3 dx. You get it right? Good. Here we're going to place in the upper boundary minus the lower boundary. We integrated with respect to y. So in this place now, in this function here, anywhere we see y, we replace it with the upper boundary minus. Anywhere we see y, we replace it with the lower boundary. Here is what I mean. We have the integral from minus 5 to 4, placing 3. Anywhere we see y. We're going to have 2x in place of y, we'll replace it with 3, minus. Here we have y in place of y, we'll replace it with 3 raised to power 4, all in bracket, minus. Anyway, we'll see y now, we'll replace it with 0. We're going to have 2x in place of y, 0, minus y raised to power 4 in place of y, we'll replace it with 0. So we'll see that in this place where we have, or we will replace y with raised 0, it's going to give us 0, right? Good. Now, here we're going to have 2x multiplied by 3. It's going to give us 6x. Then minus, then we'll say 3 raised to power 4. It's going to give us 3 times 3 times 3 times 3. When you say 3 times 3, it's going to give you 9. 9 times 3, 27. 27 times 3 is going to give you 81, right? Good. So here we have 6x minus 81 in bracket dx. So here we have the integral from minus 5 to 4, 6x minus 81 dx. We just evaluated the inner part of this integration. So let's integrate now with respect to dx. Okay, so when we integrate, we are going to have 6x squared all over 2 minus 81x over the region minus 5 and 4. Okay, so when we say 6x squared divided by 2, it's going to give us 3x squared. So here we have 3x squared minus 81x over the region minus 5 and 4. Right? Good. Let's place in the upper boundary minus the lower boundary. So we're going to have 3 open bracket 4 raised to power 2 minus 81 open bracket 4. This is the upper boundary. Then we'll say minus open B bracket, we have 3 open bracket minus 5 close bracket squared minus 81 open bracket minus 5. So here when we say 4 raised to power 2 is going to give us 16. 16 times 3 is going to give us 48, minus when we say 81 times 4 is going to give us 324. So here we have 48 minus 324 in bracket. Now going to the other side, we have minus 5 squared is going to give us 25. 25 times 3 is 75. Then we have 81 times minus 5. Here we have minus 81 times minus 5. It's going to give us plus 405. So in the first bracket, when you say 48 minus 324, it's going to give you minus 276. Then we have minus, when we say 75 plus 405, it's going to give us 480. So here we have minus 276 minus 480. It's going to give us minus 756. You get it right? We evaluate. It gives us minus 756. So this is the area of the bounded region minus 5, 4, 0, 3 from the function 2x minus 4y cubed. So we evaluate the double integral and then we have minus 756. All right? Yes. Thank you very much for watching. Let's take more examples. Stay blessed.